Okay, who wants to read this first situation? Yes, Chris.
The function y equals 50x can be used to determine the cost of taking a group of students to the Strong and Mendez concert. At least 15, but no more than 20 students can go to the concert. Represent the situation below.
Very good. So, whenever we're doing our domain and range, the first thing we need to determine is if this is discrete or continuous, because we write our discrete and our continuous domain and range differently. If it's discrete, how do we write our domain and range? List. Thanks, Enzo. We list them. What about if it is continuous? We use inequalities. Very good. Okay, so before we are going to determine if it's discrete or continuous, let's think. What are the two things that are changing in this problem? The number of people going to the concert, and then the people will affect the total cost. So those are the two things that are changing. The number of people going to the concert and the total cost. Okay? So, can you have 1.5 people? No, so this only exists at whole numbers. If it only exists at whole numbers, then it's what type of situation? Discrete. Because remember, discrete means it happens at distinct points. Continuous means it can happen everywhere between a starting and stopping point. We're not going to have 15.25 students go to the concert. Okay, so almost always if we're talking about people, it's going to be discrete because you only can have whole number people. Okay. We don't even have to write the equation because it already gave us the equation. What's my equation they give us? Y equals 50x. Okay, so now we need to determine, is my people my x or is my people my y? Is my total cost my x or is total cost my y? So think, do we first determine how many people are going and then you buy the tickets and pay, or do we first pay and then we're going to invite the people? People first. So if people is first, people is your x or your domain. So if people is your x or your domain, the range is the total cost. And I'm going to put total, not just cost, because if I just put cost, are we saying the $50 for a ticket? No, we're talking about the total cost, okay? So, since it is discrete, we are listing out our domain. And we don't know domain is number of people. What's the smallest number of people that can go? 15. All the way up to 20. How are we going to count? By ones, by whole numbers. We have 15, 16, 17, 18, 19, and 20 people that can go. Like I said last class, you use your equation and your domain to figure out your range. Okay? Normally the domain you can figure out just by reading the word problem. The range you have to use some calculation to figure it out. Okay? I'm also listing it out because it's discrete. If 15 people go, how can I figure out the cost? 15 times, and you get, so if 15 people go, it costs $7.50. If 16 people go, it costs, if 17 people, 18, 19, and 20. Is there a cost or a range value for every number of people or domain value? Yes, there should be. Okay, again, how did we find these? Substitute your x values or your domain values into your equation to find the corresponding cost. What do we notice about the cost, guys? Goes up by 50 every time because it's 50x. We're adding 50 for every person that's going. Okay? Are we okay with how we got our domain and our range? Okay, now we are going to make our graph. Our graph, the x, which is your domain, is people, so number of people. I'm not going to be able to count by ones because there's only 10 dash marks and I need to get up to 20 people. So what do you all want to count by? Twos? That works because 2 times 10 would be 20. Does that get up to my maximum number of people? Yep. Again, I don't like to label every one, so I'm going to say that's 2, then label 4. 6, then label 8. This is just to make it less messy. So we're counting by 2s, but we're labeling by 4s. Could you label every dash mark? Yeah. Could you count by something different than by 2s? Yeah. You just need to make sure it fits on your graph. Okay? Okay. My y is going to be total cost. What do we want to count by on the y-axis? By 100? So 100 times 10 would be 1,000. Is that my max? Yep. And again, I don't want to label every one, so I'm going to label every other. So 1,000, then I'm going to label 2,000. 3,000, well, 100, sorry, so 200, I'm sorry. 300, then 400, then 500, then 600, 700, then 800, 900, and then 1,000. Those would be some really expensive tickets if we were going up by 2,000s. So that's a 200, guys, not a 2,000, sorry. So 200, 400, 600, 800, and 1,000. Labeling every other one. Now, these are not going to be perfectly plotted points because we're going up by 100, but my cost is going up by 50. We're going by 2 on our x-axis, but my people are increasing by 1. So it's going to be a little off maybe, or we're not going to be on perfect intersections, but that's okay. So 15 people would be in between my 14 and 16, and the cost associated with 15 people is 750. So that's in between my 700 and 800. So see how that's in between? 16 people is 800. That's a nice dot. 17 people is 850. 19 is 900. Sorry, 18 is 900. 19 is 950. And 20 people is 1,000. So you kind of go from like a bad point to a good intersection, a bad intersection to a good intersection. Okay? Should I connect these points? Why? We're discrete. There's not a cost associated with like 15 and a half people. These are the only distinct points that my graph exists at, because those are the only possibilities of number of people that can go and cost for the tickets. Okay, now let's do our mapping diagram. You just do your domain in order, small to big, no repeat, which is already the order of my domain. And then your range, same thing, small to big. And then we need to map them. 15 people cost 750. 16 is 800. 17 is 850. 18 is 900. 19 is 950. And 20 is 1,000. Remember, when you're doing your mapping, you're going from your starting x value going to your y value. Good? Now let's do our table. 15 is paired with 750. 16 has a cost of 800. 17 has a cost of 850. 18 has a cost of 900. 19 has a cost of 950. And 20 has a cost of 1,000. And then we're just now writing them out as ordered pairs. Remember, when you write your ordered pairs, what must go around them, guys? Parentheses. Otherwise, it's just a list of numbers and not an ordered pair. So this is multiple ways for us to represent this same situation, okay? We represented it using domain and range, our graph, our mapping diagram, our table, and our ordered pairs. That helped us a little bit? We're going to do another one, okay? Do we have questions about this one? Again, guys, if we're talking about people, people will almost always be discrete. Yes, sir?
Is it going to look just like this in our list?
No. It's going to be multiple choice. So I'm going to give you a question. I could give you this and then say, tell me the domain for this situation. And you don't have to do all this. Okay? Now you might have questions on your test that look like this graph, and then it says, what's the range? So you have to go from this to the range. Or I'll give you this, and it says, what's the domain? You have to go from this to the domain. Okay, so that's why we're tying it all together, because I could ask you in any number of ways. Okay, who wants to read about us buying gas in Tim's car?
The cost represented by Y to fill Tim's car with X gallons of gas is $2.50 per gallon. His car holds a maximum of 28 gallons, representing the situation.
Very good. So what two things are changing in this problem? Total cost and number of gallons. Okay? How many of us have ever gotten gas for our parents before? Like you've been the one pumping the gas. How many of us have ever paid attention when our parents were getting gas to the gallons and the cost? Okay, my guess is most of us have paid attention. Can you get 1.5 gallons of gas? Or on the little thing, do you have 1 gallon of gas and then now all of a sudden you have 2 gallons of gas? Or does it continually go up? It continually goes up, okay? It's not like, okay, I'm buying exactly 1 gallon. I'm buying exactly 2 gallons. Your tank might be full if you're at like 10.37 gallons, okay? So is this going to be continuous or discrete? Continuous, because it's continually going. Your gas is continually going. So this is continuous. You can have a decimal of a gallon. You can have a decimal of it, it's going to be continuous. Okay? So let's write our equation. It says the cost, y, so y equals 250. What's that word per mean in math? Multiply by the gallons, x. So y equals 250x. Well, it tells me in this one, guys, which variable represents what. It says that x is my gallons. So my domain is my gallons. And it says that my y is my cost, total cost. And it's continuous. If it's continuous, we use inequalities. Don't list it. List is for discrete. Continuous, we use inequalities. So what's the smallest number of gallons of gas I can buy? 0. I'm not buying gas right now. Less than or equal to x, less than or equal to. What's the most gas he can buy? 28. That's as much as his tank holds. He can buy anywhere from 0 gallons of gas to 28 gallons of gas. Okay? So now we need to find the cost that's associated with him buying 0 gallons. If he buys 0 gallons, what's his cost? $0. Less than or equal to y, because we're doing range. What's my most cost? What's my highest cost? $70, because 28 times 250 is 70. That's a lot of money to spend on gas, but 28 gallons is a lot of gallons to put in your car too. Okay, we go with that? Okay, so I'm going to label my x-axis gallons. It needs to go from 0 to 28, so what do we want to count by?
7.
So if we count by 7, it would be 0, 7, 14, 21, 28. So we would only utilize that much of the graph. Do you only want to utilize that much? Let's try to use more. You want to count by fours? I think fours would be good. So I'm only going to label every other. So 4, then 8, 12, then 16, 20, then 24, 28, then 32, 36, and then 40. So again, label every other one, count by 4. So the ones I have labeled are 8, 16, 24, 32, and 40. And then my Y is going to be total cost. Now this one, Grayson, you might want to count by 7s. Okay, because we need to get up to 70. An easy way to do this, guys, there are 10 dash marks, and I need to get up to 70. What's 70 divided by 10? 7. So I'm going to count by 7, and it will fit. Okay. Again, I'm only labeling every other one. So 14, 28, 42, 56, and 70. We're counting by 7s, but labeling every other, so we're really counting by 14s on our label. 14, 28, 42, 56, and 70. So we're going to put dots on our graph for where we start and where we stop. When I buy 0 gallons, what's my cost? $0. Put a dot at the origin, 0, 0. When I buy 28 gallons, what's my cost? 70. So go to 28 and put a dot at 70. What should I do with those 2 points? Why do I connect them? Because it's continuous. Am I going to extend it past the starting and stopping points? No. Can you have negative gallons or negative costs? No. Can he buy more than 28 gallons? A maximum of 28. So no more than 28. That's why I'm stopping at 28. Okay? Now, we need to get 2 more points because it says we need 4. I only have a starting and a stopping. So we need to get 2 more. Tell me any number of gallons that you want to buy between 0 and 28. 1. Okay. What's 1 times 250? 250. So put a dot at 1, 250. Tell me another number.
2.
Now, can I give you a suggestion, guys, to make it easy? I would pick a number that I'm counting by.
16.
Because it's going to be easier to see. If we pick 1, we're not counting by ones. That's a hard point to plot. It's not wrong to do that. You're perfectly fine. You can do that. But it's going to be easier to graph if we choose one that we're counting by. So what's 16 times 250? 40. So 16, 40. It's right under 42. Okay, tell me another one that's divisible 4. Because that's what we counted by. Yes, Enzo? 24. What's 24 times 250? 60. There we go. Okay, so we're going to write our x values. So we started at 0, we ended at 28. The 2 x values we chose in between were 16 and 24. Our y values start at 0, end at 70, and what were they, 40 and 60? Is that right? 40 and 60. So when I had 0 gallons, $0. 16 gallons is 40, 24 is 60, and 28 is 70. Then let's write our table. My table is going to be 0, 0. 16, 40. 24, 60. And 28, 70. So then write your ordered pairs, 0, 0, 16, 40, 24, 60, 28, 70. We good with that? Okay. Now we are going to go on to function notation. I will tell you function notation, if you understand it, it's super easy. Okay? You're actually going to be very quick and you'll be good. But I strongly suggest you pay attention because this is something new. Okay, so what is function notation? It looks like this. That's called function notation. Now, before we move on and write more about this, do you think that means f times x? If you multiply two variables together, do you think you need the parentheses to show multiplication? No, you would just put two variables next to each other, right? So that's how I know this is function notation and not talking about multiplication. Okay? So the way you read this is it's read f of x, or a function of x. Okay? Any variable or letter can be used. So what that means is I could say like g of x, h of x, k of x, l of x, m of x. All of those mean function notation. Okay? All f of x is, it is a fancy y. F of x is just a fancy way to say y. Now you might think, why would we use f of x instead of just always using y? Okay? If I say, compare these three graphs, y equals 2x, y equals 3x, y equals 4x. Is there any distinction really between those functions, or they all start with y equals? Okay? If I say f of x equals h of x equals g of x equals, now are those identified as functions? So it's just a way to label your functions, okay? Biggest thing, guys, this does not mean multiplication, okay? F of x is a fancy y. This is not multiplication. Think of it as just a y. Would I ever try to separate that small left side of the y from the longer part of the y? No, I would never try to split it up. So we are never trying to split up the f and the x. Never trying to split this up. If we understand that, this is not very bad. Okay? It's pretty easy. And then the way we evaluate our functions is you just substitute the x into the expression for the variable, and get the corresponding y value. So you put your x into the function, you get out the y value. Okay. Now notice, above the x, it says what? Input, because you put the x in and then you get the output, which is f of x or y. Because remember, f of x and y are synonyms, they're interchangeable. Okay, they mean the same exact thing. F of x is just when we're wanting to be fancy. Okay? So what I'm going to do is I'm going to replace my x with my input. So instead of 2 times x, I'm going to do 2 times negative 1. Well, what is 2 times negative 1? Plus 3. 1. Now, before we move on to the next one, guys, I want to point something out. This says f of negative 1. That's a way of saying your x value is negative 1. Because normally it says f of x, right? But they replaced x with negative 1. So it's saying x is negative 1. Then what that equals is the y value. Another reason we like function notation. I can give you this, and can you tell me an ordered pair? Negative 1, 1. X is negative 1, y is 1. If I just say y equals 1, can you tell me an ordered pair? No. That's why we also like function notation. I can write it like this, and you can tell me the exact ordered pair that we're talking about. Okay? Next, I'm going to put in my x. Put in 0. So 2 times 0 plus 3. And that's 3. So what's my x value here? 0. And what's the y value? 3. Good job. Then I'm going to put 5 into my function. And 2 times 5 plus 3 is 13. So what's my x? And what's my y? There you go. All you're doing is substituting an x value into your function and getting out the y value. Okay? And again, just know that this does not mean f times 5. This is your function's value when x is 5. And that value is 13. Okay? So let's look at this one. I want us to get in the habit of anytime I see f of a number, underline it and put x there, because normally it says f of x. So this is telling me that x is 1. So I'm going to rewrite my f of x function, but anywhere I see an x, I'm going to replace it with 1. So f of 1 equals 6 plus 2 times, not x, but what am I replacing x with? 1. And that equals, what's 2 times 1?
2.
Plus 6, 8. So f of 1 equals 8. That 8 is your what value?
1.
Your y value. Okay. Next one, f of negative 1. Negative 1 is your x value. So I'm going to rewrite my function. F of negative 1 equals 6 plus 2 times what? X, which x is negative 1. So then I get f of negative 1 equals, oh, I put 1, not negative 1. Oops, there we go. Negative 1. Be careful. So what's 2 times negative 1? Plus 6. 4. There's your y. Okay. Last one of these. And then I'm going to be nice and I'm going to show you a trick. So f of 4 equals 6 plus 2 times 4. So f of 4 equals 14. And that's your y.
Can you show them the store key?
Do what?
Can you show them the store key?
I'm going to actually go to the table.
Tabletop.
Okay? How many of us would like to see a short way to be able to do this? Okay, let's all follow along with me. Get your calculator. If we are using the same function over and over and over again, I'm going to show you a short way to do this. Go to y equals, top left button. Make sure we're following along because we have not used the calculator a ton. Top left button, y equals, and we should all have this screen, do we? Okay, we're going to type in the function. See how it says y equals and this says g of x equals? Aren't those synonyms? They're interchangeable. So my calculator already says y equals. So I'm going to type in negative x minus 3. Okay, make sure you use the negative in front of the x and the minus in front of the 3. That's your negative. That's your minus. So negative x, where did I find the x? Maybe we're struggling with that. It's right next to the green button, the alpha. It's the x, t, theta, n. That's your x. Thank you. Mr. Barker has the fancy calculator, so I'm going to use his. Yep. So negative x minus 3. Do we all have this in our calculator? If you don't, guys, ask for help now. This is something you're going to want to know all year. We good? Okay.
Wait, so y equals, and then
Negative x minus 3.
negative.
We're putting whatever our function, this is called your function rule. We're putting function rule into our calculator. We don't have to put the y equals in again because it's already there. Okay, we good? Okay. Guys, your calculators are color-coded. On the top right, do we see that it says table in blue? Okay, so I'm going to hit the blue button, which is second, and then table button, which is top right. Oh, now I have a table. This gives me a ton of values for this function. So I don't have to do any math calculation, guys. The table did it all for me. So I want to see when x is 0, what's the corresponding y? Done. When x is negative 2, so you can scroll up. See this little circle thing? You can hit the arrow up and it goes up. When x is negative 2, what's y? Is this shorter? Easier? When x is 3, what's y? Do we like that? That was short, right? Do we think we can do one more of these and then be good? Okay.
It died.
So put it here and go get a different one. Okay, so we're going to do number 5. The way you clear everything out of your calculator is second, which is your blue button, plus, the plus symbol, 7, 1, 2. And it clears your memory. Second, which is the blue, plus sign, 7, 1, 2. You want to clear it out because we're doing now a different problem. Okay? So we're going to go all the way to number 5. Go to y equals again. Y equals is your top left button. And I'm going to do negative 2 minus 2x. Negative 2 minus 2x. How do I go to the table? Second table or second graph. I want to see when x is 4. What's y? When x is 4, y is negative 10. When x is negative 2, so scroll up. What's y? 2. It won't let you scroll up, guys, if you're in the y column. Okay? So you have to arrow over to be in the x column. So when x is 0, what's y? Negative 2. Should you ever get these questions wrong, guys? If you do it by hand, that's great. Then do it on the calculator to check yourself. We good? What's wrong? Yes. Yep, because this is different. I'm not giving you the x value, I'm giving you the y value. Okay? So let's again, bless you, second plus 7, 1, 2. Second plus 7, 1, 2. Go to y equals, and I'm going to put in 2x. And then go to the table, second table. Now I don't know the x value. It's blank. I'm looking for a y value of 4. Do I see the y value of 4? What's the x value? 2. Now I'm looking for a y value of -4. I don't see it on here. Which way do you think I should probably scroll? Up. Oh, do I now see it? What's the x value? Then I'm looking for a y value of 0. The x value is 0. Do we like those, guys? Again, this does not mean f times 0 is 0. This is saying your function's value when x is 0 is 0. Okay? Good? Okay, we're going to be done with the calculators now, and now we're going to look at graphs and tables and mapping diagrams. Okay, so P of x equals 0. So I don't know my x value, but I know it equals 0. So I know the y value is 0. Okay, so I'm going to look at my graph and find a point where it has a y value of 0. Okay? So y value of 0 would mean I didn't move up and I didn't move down at all. Oh, right there. Doesn't that point right there have a y value of 0? What's that x value? 0. Now I have an x value of 2 and I want to find its corresponding y value. So I'm going to go on the x-axis to 2. x, 1, 2. Is there any point that has that x value of 2? Right there. What's that point's y value? 2. Now I need to find an x value if I have a y value of -2. So I'm going to go down to -2 on my y-axis. Is there any point that has a y value of -2? There's 2, right? I only have to pick one. Which one do y'all want to use, the left or the right? Left. That's -1, 2, 3. -3. Could you also say 1, 2, 3, 4, 5? That point has an x value of +5. Yeah? Okay, we're doing more of these, so if we're still a little confused, it's okay. So we need to go on our x-axis to -1. -1, follow it down, and it hits right there. What's that y value? -2. I need to find the x value when y is 2. So I'm going to go on the y-axis up to 2. Follow it across. Where does that actually hit the graph? Right there when x is 1. I will say, guys, you're going to have one almost identical to this on your test where there's like 5 questions. Okay? X is 2, I need to find the y. So go to the x-axis and go to 2. Where's that hit the graph? Right there, and it has a y value of 4. Okay? We ready for I think the tables and the mapping diagrams are way easier. The graphs are a little bit confusing sometimes. Okay? I don't know my x value, but I know that y is 10. So I need to find a point where y is 10. Right there. What's the x value? 60. I know x is 48. I need to find what the y value is. Look at your x column. X is 48 and y is 8. I need to find the x value when y is -2. So I need a y value of -2. What's the x value? -12. So you're just pairing up the ordered pairs together. Okay? We good? Okay, last one, mapping diagram. When x is 1, it's paired with 0. When x is something, it's paired with 5. So 5 is the y value. 5 goes to which x value? 3 or 6. Can you pick either?
Yeah.
Yeah, both work. If If you put 6, that's right too. Bless you. Then when y is 0, what's the x value it's paired with? 1 or 8. Which one do y'all want to use? 8's bigger. I like 8. Okay. Are we good? Okay. What I want y'all to do is I want